Okay, thanks, Neil. In the clear here, no questions yet. I think we're looking good. Okay, so I'm just pulling up my screen here. Can someone confirm that they can see my screen?
Yes.
Okay, great, thank you. I need to be reminded that there's a little bit of a delay on these things, so there we go. Great. Okay, so yeah, basically, I'm just going to go through this quick start guide as Neil mentioned. Yeah, there's a general requirements here that you need access to the Digital Research Alliance machines. Specifically, you're going to need Niagara access to use the current port that we have there. And just for those who aren't used to the Research Alliance or haven't used it before, you have to opt into Niagara. You don't just get Niagara access when you sign up for DRAC, the DRAC accounts, so you need to do that. Now, with that said, let's just visit this quick start guide that Neil mentioned. So this will open up right on my browser here. And as Neil said, well, this is just loading up, taking a long time. As Neil said, this is going to be really kind of bare bones to start. We have a half an hour here. So I'm going to just go through it quite quickly, the first steps through here. And then I'll discuss some things as I do it, but I'm going to try to just be copying and pasting these commands. Now, I do want to note that this is currently just a raw restructured text file. Eventually, this will be under the docs to be better, a little better to readable. But basically, just look for these code blocks, and then you'll find the code right underneath it. And so as Neil says, you can literally just copy and paste this. So the first thing that needs to be done, actually, before I move over to that, I do just want to quickly bring up the simulation setup flow that I showed yesterday to show how all these steps kind of map onto this, right? We have to do the setup and configuration in these first two steps, compile, save the model restarts, and then you submit it. With that in mind, let's move on. So we copy this activate command, and this is going to give us access to this IMSI utility that Neil mentioned. So you can explicitly, so like currently I'm just in a raw version of, or just in my home directory on Niagara. If I see if I have IMSI, you see that there's no IMSI on my path. And so that's what this activate command is going to do, is this is going to put IMSI on my path, and it's going to be this entry location into the environments. So I'll just make this quite large just in case anyone's screens are really small. So now when you do this and you look at which IMSI, you see now that we have it, we have this IMSI binary that we have access to. This also gives us a specific Python that is related to this to kind of help run these utilities. Okay, so we have IMSI. We've gone through the first step of this. And so now if we just go further down, okay, and then this tells us to navigate to our scratch space. So navigate to my scratch space, and I will just say LRT is an alias I had for LS LRT, so that's just shorthand for it. So you'll see that a lot here. But yes, this is my scratch space, and as Neil said, we need to set up runs here, and then you're going to have to store whatever you want for long-term storage in your project space, because things are going to build up here. So you're going to need to clean this up. And the DRAC admins, they're pretty good about reminding you that you need to do this. So you'll get emails about when they're about to clean things up. But also we need to use scratch space because you are unable to submit jobs from your home directory on the DRAC machines, or at least Niagara. And you're also unable to write to your home directory from compute nodes. So this is why you need to do everything out of the scratch space. Okay, so then let's go to the next step. I'll just copy this, and then we will, here, I see that there's a question, Neil Tandon.
Yeah, so maybe I did something stupid, but when I did the source command, I got permission denied.
Okay. That is good to know. Yeah, we need to, yeah, and so I'm assuming you're not part of the CP4C group yet.
No,
right?
I'm doing this on my own, under my own Niagara account.
Okay, no, that's great. Yeah, if we can I recommend, this is also a good disclaimer, is we expect that this should work for other people, but we have been wrestling with kind of permissions issues on the DRAC machines. So that's not overly unexpected, but it is something that we should sort out. So we can touch base about testing that and fixing that after the demo here.
Sorry, can
Could I just confirm that? So sorry, Neil, you said when you try to source that IMSI environment that it said that permission denied?
Yeah.
Okay, I'll look at that quickly on the side here.
Thank you.
Okay. Okay, and so now before I just paste this command, I want to just kind of show that you can do IMSI -H, and this gives you some nice output that tells you kind of these subcommands that IMSI has. And as Neil mentioned, these are kind of these utilities that are used as entry points to interact with our repository, the source code, and avoid human error. We're going to step through just the setup and the build and submit commands here. These other ones are also quite useful and map quite nicely onto that setup flow that I showed earlier. But specifically, let's look at the IMSI setup command help output. And this is where we're going to see that run ID. These are the run identifiers that Neil mentioned earlier to identify a run uniquely. People often ask, what's the run ID? It also lets you look at things on the RTD browser easier. The repository comes directly from the repo. I will just also show where you can find that up on the top right on GitLab, and you'll get the you can get the SSH address, or you can use the HTTP address. I will note that if you don't have your SSH key set up, you can use the HTTPS to clone. But I will note that it is generally recommended to set up your SSH keys to work with GitLab, so I recommend doing that. But you can still use HTTPS. And so this is whatever repo. It could be from your fork. And then also there's a version flag, and that's where you can see the branches here. That can be a branch, a commit, or a tag. We're going to use the 5.1 CP4C branch because this is the one that supports the CP4C effort. And then the last two that are important for this setup currently are the experiment and the model. These combined together have to be a model that is supported for the given experiment. And this is going to define a whole slew of downstream configuration settings. And this is where there is a bit of a blurring of the setup and configuration step with this setting. You can still do extra configuration after you run the setup command, but this just gets you the initial starting point for your configuration. So with that, I have that copy and pasted. So I will go back to the quick start. Do this again. Okay, so paste it. I'll just change the run ID. Just call it Clint's test. And so now what this is doing is it's cloning from the repository, and this is where you're seeing notes about all these kind of sub-modules. And so this is what I'll touch base on kind of what these are a little more this afternoon when I discuss the code layout. But yes, there's kind of individual repositories underneath, and all of these need to be cloned and checked out to the right versions. And so this is just kind of following this ethos that besides this entry point that IMSI has and some like obvious on disk dependencies you might need about like figuring out the NetCDF libraries and stuff like that, everything else should be contained within the repository. And so that's why all of this is being cloned on every time. It can take up a lot of extra space, or not a lot of extra space, but it can take up some extra space, but it really improves reproducibility by ensuring that if you have the version of the repo, you can get all the files and codes you need to actually run the model. So let's just follow the directions. So you will see that there's a new directory here. So let's just navigate into this. And now if we look at the contents of this, you'll see that this is the actual CAN-ESM repository. And then I won't touch on these files here yet, but then there's this listings directory. It's currently empty. The listings directory is going to contain the outputs, the standard error and standard output for both the model running and the diagnostics running. I'll discuss kind of the separation between those here shortly. And then the config directory is where is the configuration files that actually get used by the run. These are produced from kind of your upstream configuration choices, and these define kind of the input files, the environments, and underneath each of these, you'll find name lists for the various models. And so you'll find the AGCM name list under CAN-AM, likewise the coupler and CAN-NEMO. And then the last thing that comes out of here is this temporary save restart file script. And this is to help interact with that file management system that I introduced yesterday based off of the parent run that is defined with this configuration. it will get those, and you can save it from there. But out of the box, this configuration already has some centralized restarts defined, so you can just run this later on. And lastly, this imz config JSON file. This contains all the information that is used to produce that downstream config directory. I'm not going to show the contents of it, but it's quite long, and you can take a look at it if you'd like. But if we look at this, like it's 871 lines. There's a lot of configuration in here. So feel free to take a look if you'd like to work on changing something, which we'll discuss later. But as of now, let's just leave this as it is. And now the imz submission dash run ID script. This is for Niagara specifically. This is a Slurm script that is used to submit the model running. imz diagnostics is the equivalent, but just for submitting the post-processing jobs, which is a direct map onto all this post-processing steps that I described yesterday. This is going to cover all these aspects, while model run's going to cover that. Okay, and then so we have everything set up, and so now if we just go back to and just remind ourselves what we've done, all we've done is activate the environment and run the setup command. Now, all you got to do is just run imz build once you're in there. And this is going to do the next step in the setup flow. And this is just going to build things for us. imz build. And you're going to get a bunch of messages about what it's compiling. This is interacting with a temporary compile script that is going to be extracted. You can look at it if you like. And then there's some environment messages. We should and we will try to clean up some of the outputs here. But I will note that these outputs are expected. Now, as of now, this takes a bit of time. So I have something ready where everything is compiled already. So let's just move over to that. So here's this temporary compile script that gets popped out. You can look at that if you like, but just know that the compilation is happening underneath. And eventually what you want to see out of this is you want to see a binary directory, a bin directory that looks much like this. At the very least, you should see an emo executable for the ocean. If you're running ESM, if you're running AMIP, you won't see that. But if you're running AMIP or ESM, then you'll always see a CAM executable if things have gone successfully. You'll see a CAN couple executable if that's also worked. And then additionally, you should see a bunch of these kind of Nemo diagnostics and supporting binaries that get compiled, and they're linked back to the repo because they're built in source with the repository. And then likewise, bin diag is what contains all the CAN diag programs, which interacts with CAN-AM. Now, I'm not going to point out, show all these files because there's a lot of binaries under here, but I will just show the number of them. Yeah, so we have 129 different programs in there. So if you'd like to go into the building of those, you can, but 99% of users probably won't. So just keep in mind this is what you want to see. If you don't see these executables, you can, if you do ls, but with the -a command, you'll see these hidden compile logs. And so these compile logs are broken into each individual component as they run different build systems, essentially. And you can take a look at these. So like if we just tail -n50, the CAN diag build log, we see all the compilation output, you see all the flags. Now, I will note that these flags come from the config directory. That's all I'm going to say, and this is based off of the machine level configuration. But at the very least, that's all you want out of the compilation process. You want these executables. Gotta make it a little smaller. Yeah, you just want these executables, which are going to facilitate running the model and any of the post-processing steps. Okay, so we've gone through the setup, we've gone through the build. Now the next step is to save the restarts. So how do we save the restarts? Well, let's just go to the commands and we see save restart files.sh. So we'll copy and paste this. And so this interacts with the centralized database on the CP4C space that exists within that space that Neil mentioned this morning. And there have been some official run IDs, official restarts associated with run IDs saved. And there are a bunch of defaults defined for each of these experiments. Now, for the pre-industrial control experiment, we're starting from another pre-industrial control just because it's going to keep spinning up. That's the desire. And so it is using this run ID V510 PI control. So this is our one of our early 5.1 PI control runs for the end of the year, 5,999. It's going to find that restart in the databases, and then it's going to rename it with the run ID associated with the run I'm using, and then save it saying, okay, it's starting at year 6,000. And so you can see one for each of the restart types that I mentioned yesterday. There is also a snapshot of the environment saved just for documentation purposes. But once this is done, you will see an output directory in the run directory. So you can look in there and see what this looks like. And you can see the restarts here. They have an addition number. So this means that if I was to save them again, it would get toggled up to 002. And then that means when I run access later on, it's just going to get that portion of it. But at the very least, we've saved the restarts we have for the run. And so we've gone through that step of the setup flow. So the next thing we need to do is just submit it. And it's as easy as using IMSI submit here. So IMSI submit is a wrapper around the Q sub or PBS. We have it to support both of those. So that's why there is just a little bit of an abstraction there, because we have to support multiple queuing systems. But so then you just do IMSI submit, and it gives you the batch job ID. And if you check SQ, you'll see that you now have a job in the queue. A couple things I want to highlight. It's not running yet. That's just because resources and this priority. So we don't have access to those resources yet, but we will eventually get them. As Neil alluded to earlier, we're running on 6 nodes with 240 cores. The wall clock time for this is 3 hours. And for me, I am automatically submitting to the RPP CP4C project. Now, I'm just going to give, so this isn't going to run right away. Also, SQ is a nice alias that DRAC supplies, just for shorthand for what I just executed. This isn't going to start running anytime soon, or at least not immediately. It'll probably take a bit of time. So to just show what things look like as things run, I have another run here where we have some output and listings that we can look at. So Neil will go into the output more, so I won't really dive into this. But if you look in the output directory for each year that's submitted, you will see a subdirectory for the defined year. And that's where you're going to find these time series files that Neil alluded to earlier with kind of the trimmed down ones. And we'll just kind of show what that looks like for year 6,000. And so these are all these time series files. These start with the prefix called SC, and they are a single variable per file. The netcdf files are the ocean files, while the ones without netcdf files are the AGCM files. And then you also have this nice NC output directory, where this is where the semerized netcdf data goes after things run. So if you do type F, look for all of them, you'll see a big long list of all these files for each individual year. We get 413 out of the box variable files for each individual year. And then the last thing to note is now the listings directory actually has content in it. And you can see, so there was just I'll start at the start that I'll just ignore. But outside of this, I ran the model for 2 years. So that means I had 2 model chunks of a single year run. So that's why I have 2 run CANISM output files. And that means I had 2 post-processing jobs that also ran. And these are the job IDs. And so you can look at these. I will note that the running of CANISM, those ones are really, really large. And that's because we have hundreds of MPI tasks that are all running and outputting are streaming their output into these files. And so that's why these files get pretty large, so 158. So you can cat these files, but it's going to take a while. But at the very least, when things crash, these are the files you will open and look for, and you will look for things there. If I just show tail m minus 50, look at this. And so this is just kind of a bunch of S control stuff that comes out at the end of these Slurm jobs on DRAC. So that's not super important, but you'll see here at the end that there is, so this is the first 6,000 years. So basically this, after this chunk, it checked its dates and it's like, oh, I want to submit another year of the model. It submitted another year of the model. And then it also then submitted its downstream diagnostics for said year. And then likewise, you can even look at the diagnostics output if you expect that things failed there or you're not seeing what you expect. And so this is kind of the starting bare bones of this. There are some simple changes that I can do. We still have a bit of time, I believe. I think at least 10 minutes here before this section's done. But we can
maybe we
discuss.
should pause and see if there's some questions.
Yeah, exactly. Yeah, so if there are any specific questions, we can discuss that now. Christian.
Thank you very much, Clint. That was great. I have a short question concerning the restart file. So let's say I just do an out-of-the-box run without any changes in parameter values or whatever. Is it safe to assume that those restart files already reflect a model state that is completely spun up? So if I just want to do the historical run, I can just start from there. I don't need to do whatever 2,000 years or longer in order to spin up. Okay.
Yeah, exactly. So as I think Neil showed that if you line up, these are quite equivalent to some of the bigger reference runs that we did internally. So yeah, these have a fully spun up climate. So you can go from historical. If you wanted to use the SSP experiment, you can use a historical that will be relevant for the end of the historical period for that SSP experiment as well.
Great. And then my second question, in class C or in classic, Joe has taken all the parameters and put them into a parameter file so you don't have to recompile the code. Now you have just class C10. I don't know how far that goes back. If I want to change a parameter, is that typically then for class C10 in the source code, or is there a text file that I can edit so I don't have to recompile the code?
That is a good question. Jason, is Jason Cole on the line right now? He might be able to answer that actually. Because I know we have done a lot of work to actually pull out as much of those configuration parameters into name lists.
Yeah.
Oh, great. Deji's online. Deji can probably answer this. Deji, can you speak to this specifically?
Actually, you don't need to modify any config file anymore. So it's there's no CPP key in class C10 anymore. So you just need to make the changes in the code and run it.
So does the name list? So name list can take in these parameter changes, Deji?
It depends on what parameter changes you're talking about. At least all the user-defined parameters are now through the name list.
Okay. So yeah.
Well, I think for that's true about the CPP keys. So yeah, it used to be a lot of CPP key stuff that you had to recompile. But Christian, as you noted, that was a change for Classic. So for Class CTEM, although for CanAM, we've advanced a lot in, there's a file CanAM settings that has, and we'll see this a bit more later, but it does have most of the settings. But for Class CTEM, a lot of those parameters do still actually exist in the code. So when 5.2 is released and Classic comes, that'll be an improvement. But for the current state as it is, there's not actually a huge amount of parameters in name list files because it is still Class CTEM.
Well, it really depends on what you mean by parameters. If there are real model configuration settings, like Classic CTEM doesn't really have many. There's some constants that are set in the model. Like if you want to change them, you have to change the code to change. But in terms of model configurations, Classic CTEM doesn't have as much. The only one that is really mainly used is the DRN GAT setting, and that's in the name list. It's in CanAM settings.
Okay, thanks.
Okay. Is there any other questions?
I'll just add to the question about the restart. So because this actually is a divergence, it's an improvement over what we have internally. So the way that the experiments are set up, that whenever you set up an experiment, one of these supported experiments that we have, it will automatically by default give you a sensible restart. So let's just say that you're going to do if you're going to do a historical run, it'll give you a PI control restart. If you're going to do a 1% per year run, it'll give you a PI control restart. But if you're going to do an SSP 370 run, it will automatically give you a historical run as the restart. So it does that automatically. So it gives you a sensible default. Of course, users can change that, and we'll actually do that later, but you do get a sensible restart by default for any experiment that we have configured.
That's great.
Okay. Are there any other questions about kind of the setup? Yeah, I do just want to highlight all I did for these commands was just went through copy and pasting of that quick start. So we do need to sort out some of these permission issues, and Neil is on that right now. But these are little teething issues that we should be able to solve. And if any of those things come up, you can ping us on. If you're part of the CP4C Slack, feel free to ping us there. But one of the greatest ways to notify us that there's a problem with the CP4C branches is on our public repository, the gitlab.com for a CCCMA CANISM. Feel free to open an issue there, and we will be notified of it and get some work on that as soon as we can.
Yeah, just to mention, so we did resolve that specific issue that Neil had.
Great.
That was punishment for updating the environment a day ago.
Oh, right.
And they're not setting the missions correctly, but no, that's resolved. But then Neil did hit another issue, so I think Clint did mention this, but then it's been discussed in the chat. So if you have put your SSH keys onto GitLab, that copy and paste instruction that's in that quick start guide will just work by pasting it. However, there is an assumption that you've put your SSH keys onto GitLab. So Neil hit the situation that he hadn't done that, which is probably most users, and you can get around that quite easily. And the solution is you just have to use a different address. So on the minus repo argument, you have to use a different address, which is an HTTPS address, not a Git address. Yeah. And Clint could show you that. Yeah,
it's right up here. So when you go to the code, I showed this, that you can just copy and paste this address and use it instead. And it works. It will work great if you don't want to set up your SSH keys. The recommendation is to eventually set up your SSH keys. If you do want to contribute and you want to make any modifications, I highly recommend you set up your SSH keys. But if you just want to clone and run it, feel free to use the HTTPS.
Yeah, I did think we should probably put a note about that in the quick start guide. But the recommendation is to use it SSH, but it won't work.
Yeah, that's a good point, Luke. Yeah, we can note that to add that here.
Yeah, and I was able to get to submission of the run after addressing those two small things.
Fantastic. So our prereqs are true now. So there we go. Thanks for testing that live, Neil.
Can I just ask a quick
Neil, you're muted.
question? So yeah. I was following along with like compiling with IMSI, and I got a few error message about like modules not loaded. Like, so it replaced an HDF5 MPI or NetCDF MPI with the non-MPI versions, and I don't like, but it did compile. I don't know if it will properly or not, though. Could you?
Yeah, no, as I mentioned, that those messages, I do want to find a way to suppress them and make it so that we're doing all that totally consistently. But as of now, that's expected. And if you get the binaries out in the bin, things should be okay. Obviously, if you find when you launch the model, you get some weird seg faults or something like that, or libraries not found, by all means, feel free to ping us. But currently, that's the expected aspect of it. We've been wrestling with trying to get like the modules properly all set up on the Niagara. There's just some inconsistencies that we've struggled to deal with all the time. But as of now, these ones do work. It's just you're going to get a bit of messages from the build step.
Okay. Yes. Sorry you did mention that. I was kind of half looking at my own code output at the same time. So sorry about that.
Oh, good. No worries.
Okay. If we have time for just like one more question. So just to be clear on as people are trying this like right now in the next few days, how would you recommend this communicating about it? If it's it seems like people are running into similar problems. Should they start using the repo and the GitLab for reporting questions and issues, or what would you say at this point? If they're not, let's say they're not on the CP4C Slack, they're sort of outside and using it.
Yeah. So if you're not on the CP4C Slack, well, first off, it is a good place for like as a community to discuss these things together, and there will be a lot of kind of community support there, which is the purpose of it. But I will say that opening an issue on the repo is also fine. We can close them once we figured out the problem. Like that's the right way to do it. But as of now, those are the two methods that I would recommend. Neil, you might have another idea on here. I don't really see another alternative outside of emails directly to us.
Well, so one thing that we have not used extensively, but I think could actually work quite well for us. I'm sure we all know and love Stack Overflow for solving all of our technical problems. Maybe a bit more before ChatGPT arrived, but anyway, there is something called Stack Overflow for Teams, and we do have a CannySM team, and so actually. The thing with Slack is that information gets lost because unless you pay for it, and it can be hard to find information. The nice thing about Stack Overflow for Teams is like the questions that are asked the most will just like naturally float to the top. And so, communities, the best solutions will also just naturally float to the top. So I would recommend that. Like there is a link again on the wiki to these things, but people do have to join. So
I do want to just flag a bit of a snag on the Stack Overflow for Teams. Neil, is the free version does have a limit of people that can sign up for it, and I believe it's 50. So that is just something that we're spares. Yeah, so like we're already close to that wall now. So by all means, if you want to use that, sign up for it now. But it is that's just I wanted to note that if we do actually want to expand that to be a more general use, we would need to find a way to expand the number of allowed users.
Yeah, I guess I could say like for I think we have to be a bit careful, Clint, about just saying just open issues on our CannySM thing because there's some kind of implication that we're going to respond to those, and I don't know that we can respond to thousands of issues. But what we do intend to do is set up like the support center on the CP4C project. We just didn't quite get there for this tutorial, but we will communicate that there is a good channel. But yeah, I would say like probably the Slack is the best option right now. Yeah, you can open issues, but we also the reality is, as Paul mentioned yesterday, there's nobody that really 100% has the mandate to do user support at this instant. And so CP4C is hopefully getting a big GNC from Environment Canada that will pay for a support person, basically. But that person is not in place yet. So we do just have to be honest about our limitation in not just being able to invest countless hours resolving every individual's issues. So like, I just want to be honest about that. We can't commit necessarily to that. We try to make sure that it works, basically, but okay. So I think, sorry, go ahead, Paul.
Can I just to say, let's talk about it tomorrow again. I was opening a small can of worms. I thought I was just sort of slightly popping the top off, but it's they're starting to jump out. But just to say, like, I don't think we should decide right away, but maybe if people are gathering their questions, right? They could like write them down now, and rather than send them one at a time during the workshop, kind of put them together, and we can start talking about those outstanding questions tomorrow. And then I think that the best short-term solution is the CP4C for Slack, and joining the CP4C email list, and because we're in our technical meetings, all the notes are readable, so you can come to the meetings, or you can just read the notes from past meetings. We're trying to work through those technical issues, and that's as far as I wanted to get today. But it's important, and we need to have those issues written down. It doesn't mean that we can solve it right away, but we need to write them down and put in order of priority what we need to do next, right? So that's the technical issues list. Thanks very much for a great overview so far.
Right. Okay. So I think we're at the kind of time for that. I mean, we can come back in the breaks and so on. And there's a lot of time at the end for general questions and discussion. So hopefully we will have additional time. But I think just for the purposes of staying on schedule, we'll keep going